This is considered very critical wells because you should focus and for any kind of flows, and you have a challenge because you use a specialized drilling fluids, you use specialized muds, not the normal mud systems. Overbalanced, that overbalanced means that you have too much pressure on the formation. It may break, and if it break, we have something called losses of the drilling fluids. And you have something called reservoir drilling fluids. Reservoir drilling fluids is called about mud drilling the reservoir. Mud drilling the reservoir, any content of the mud should be acid soluble. Should be what? Should be acid soluble, not to block the pores of the reservoir. So let us have an overview about the drilling fluids. To better understand the drilling fluids, you should understand the functions of the drilling. If you grasp all the functions of the drilling fluids, you will be fully aware of all the aspects considering the drilling mud. So let us start with function number 1. Function number 1 is to minimize fluid invasion into formation. Minimize fluid invasion into formation. Because if we have too much fluid go into the formation, we will have a thick layer of solids between the formation and the drill string. It is called filter cake. If we have a big filter cake, we may have a stuck problem. Stuck problem means we can't drill anymore and we have to make a side track, or we can make another well to drill. Function number 2, prevent the flow of oil and gas while drilling. The flow of oil and gas while drilling mainly depend on the pressure exerted by the drilling fluid column. If the fluid is heavy enough, means it have enough density, it will compensate the pressure of oil and gas flow. So we are safe and well is in control. Third, we lubricate the drill string. One of the most important functions of the drilling fluid is to lubricate the drill string in order to decrease torque while drilling, in order to facilitate the drilling itself, and to increase the rate of penetration, aka ROP. Fourth, transmit the hydraulic horsepower to the bit. The hydraulic horsepower to the bit, we drill with GBM called the flow rate. We drill with the flow rate according to the formation. So there is a force of pumping the fluid into the formation and so enhancing the drilling operation itself. It is calculated according to the software to maximize the force at the bit, and using two concepts, were either the horsepower concept or the impact force concept. So we can drill efficiently and safely. Also, we want to maintain a stable engage well bore. Maintain a stable engage well bore means that the whole well is homogeneous. There is no ups and downs. There is no ledges. There is no edges in the well. Maintain a homogeneous, exactly the same size. You drill, you want to be homogeneous. If you drill 22-inch hole, you need 22-inch hole. If you drill 16-inch hole, you need 16-inch hole, and etc. Let us talk about one of the most important functions of the drilling fluids, and maybe our jobs as mud engineers now is invented. This property is called minimize shale hydration and dispersion, and the scientific term of this is shale inhibition. shale inhibition. What is the meaning of shale inhibition? Shale inhibition is the process of controlling shale. Shale is clay formation compacted under certain depths. We called it shale, not clay. So if we find clay as a surface, we call it clay normally. But the compacted clay found at the depths, it is called shale. Also, we need to minimize reservoir damage. We need to minimize reservoir damage by using acid-soluble chemicals, as we said before, and to maximize the rate of penetration, the ROB. To maximize the rate of the penetration, we use certain chemicals. We adjust the mud weight accordingly and several factors. Okay, just give me 1 minute, I will come back. As we were saying, we have different functions of the drilling fluids we should be aware of. So next slide. This is typically the drilling fluid we are using. It is muddy in shape, can be several colors, maybe gray, maybe a brownish, maybe reddish, according to the ingredients or the recipe you are working with. The drilling fluids we know is generally two types, the water-based mud and the oil-based mud. We will talk later about the different types of the drilling fluids. Let us discuss the history of the drilling fluids. On August 27, 1859, George B. Searle and Edwin L. Drake made the first successful use of a drilling rig on a well drilled especially to produce oil. This is the exact date of the first officially drilled well. It is on site Oil Creek near Pennsylvania. Drilling fluid used was clay from nearby wetlands mixed with water to remove cuttings from the well. So previously used mud was just water we mixed it with clay to clean the well, from the well. This is the most important function of the drilling fluid, is to remove cuttings from the well, and it is logic to continue drilling. As drilling progresses, every day new techniques and technologies are invented, especially in drilling fluid systems and chemicals. The drilling fluid evolution through time. Nowadays, drilling fluid mud is classified into water-based mud and oil-based mud. It is very simple. If you want a water-based mud, you will use water and mix water-based mud chemicals. If you want oil-based mud, you will use oil, maybe diesel, maybe sulfur oil, maybe any kind of oil, and then you mix oil-based chemicals. Water-based mud is mud mixed on water, so water is a continuous phase. Oil-based mud is mud mixed on oil, so oil is a continuous phase. So if you really want to understand about drilling fluid, you should know and deeply understand drilling fluid functions. These are the detailed functions of the drilling fluid. There are 13 functions as per MI SWACO. I think the best service company in the world regarding drilling fluids. First function is to remove cuttings from the well, as we said before. And secondly is control formation pressure. You control formation pressure using your weight of the mud, as we will discuss later, to suspend and release cuttings. suspend when you make the fluid static. Because when we drilling or we circulating this dynamic motion, when you make the fluid static, you need the cuttings in the fluid to be suspended, not to fall down and cause problems. And also, when you reinitiate or restart circulation, you need to release the cuttings. The fourth one is to seal permeable formations. Sealing permeable formations, make good filter cake. Maintain wellbore stability, as we said before, to make the whole well homogeneous. Minimize reservoir damage by using acid-soluble chemicals. To cool, lubricate, and support the bit and drilling assembly. Transmit hydraulic horsepower to the tools and bit, and to ensure adequate formation evaluation. Ensure adequate formation evaluation by evaluating the cuttings on the shale shaker. Controlling corrosion. When you adjust the pH of the mud, you control the corrosion. To facilitate cementing and completion. Facilitate cementing and completion. When we are cementing, we need a low rheology mud. And we are completing the well, and when we are completing the well, we need special type of brines. Brines means water with salt. Minimize impact on the environment. Of course, any chemicals or any waste products should be disposed in the appropriate way, accordingly to each waste we are using. Also to prevent gas hydrate formation. Prevent gas hydrate formation. This is found in the deep water drilling wells. When you are drilling 4,000 feet below the sea surface, you will find the fluid get colder and colder when it goes down to the well, and then get hotter and down to the earth, and then vice versa. When it is coming up, it will be colder, colder, colder until it reaches the surface. This form what is called by gas hydrate. So we use a special type of chemicals to drill these deep water drilling wells. This is the course outlines I used to give to my students. It is about the mud types, functions, rig system, and calculations. Mud types and mixing contaminants and chemicals. Of course, we will only talk today about the functions. Okay, this is our first session. You may take a break for 10 minutes and maybe come back again. Thank you. So now we are talking about the functions of the drilling fluid. And take short notes about this. As we are saying, we talked before about the hole cleaning and the pressure control, suspending solids, minimize formation damage, isolate flows from the formation, cooling and lubrication. Now I am stating the functions of the drilling fluid, but I will explain later. Also power downhole tools to save the environment, maximize the hole information, to prevent corrosion, and to support part of the drill string. And of course, my brothers, to save cost. And this is the main subject of nowadays, cost reduction. Hopefully, cost reduction didn't touch you yet. So, first subject we are talking about is hole cleaning. How we clean the hole from cuttings. You know, cuttings main force acting on cuttings is the gravitational force. So normally cuttings are coming down, not coming up. So how we can remove the cuttings from the well? We can use two forces. First force we are talking about is the annular velocity. What is the annular velocity, brothers? The annular velocity is the velocity of the fluid itself. And the velocity of the fluid itself can be enhanced by increasing the flow rate. And also we can use smaller or narrower sizes of the we are drilling with. That enhances our annular velocity. Because annular velocity is recorded by or calculated by the pump rate in barrels per minute and divided it by the annular volume. The annular volume, and you record the annular volume by barrels per feet. So you get the annular velocity by feet per minute. So what is the best annular velocity for the deviated holes? It is around 100 feet per minute if you are drilling deviated holes. For the large hole section will be 20 feet per minute. As for the annular velocity is insufficient to clean the hole, the viscosity must be increased. So we are talking about the top hole viscosities. We have large flow rate, but also we have large hole size. So the conclusion is we have a low annular velocity. That's why we should use higher viscosities than normal. So cuttings removal is harder in deviated and horizontal holes as the vertical component of the mud is reduced. Because if it is vertical hole as you see in front of yourself, then we are bounded by two factors: the annular velocity with cutting up, and the slip velocity, which is the velocity due to gravitational forces. That's it. But in deviated holes, you are correlated with other factors: the friction due to the deviation, and the resolution due to the inclination of the well. So it is more harder to remove in the deviated and horizontal holes. Let's go to the second topic. The balancing subsurface pressures. How you can balance the subsurface pressure? It depends on the density of the overlying rock, the pressure of the interstitial fluid, whether the rock is self-supporting or supported by the fluid, also tectonic activity and the surface terrain. These all factors that determine the pore pressure you are drilling, pore pressure of the rock you are drilling. And so you need pressure exactly equal to the pore pressure of the rock you are drilling, or maybe more by a few margin. So if you can't, or if you didn't balance the pore pressure, what will happen? You will get some problems. What problems? Like influxes of the formation fluid into the well bore, lost circulation, hole instability, and stuck pipe. So what is the subsurface pressures? The pressure balancing the formation pressure is composed from the hydrostatic pressure under the static conditions. And it is calculated by the weight of the column of the fluid inside the well. And by the way, the well should be full at all times. Under circulating conditions, the effective pressure is increased by the pumping pressure. You have already pressure of the column weight of the drilling fluid. But when you exert force to pump, this force is corresponding to what is called by ECD, the equivalent circulating density. So the static density is the normal density of the fluid. So what is the ECD? The assumed density of the fluid when we are pumping, or when we are circulating, or when we are in a dynamic motion. Next, suspending solids. Whenever the pumps are switched off, solids will start to settle. This can result in bridging of the well bore, stuck pipe, hole fill, or loss of hydrostatic. So how we can solve this problem? We can solve this problem by making a gel structure. And what is gel structure, my friends? Gel structure is caused by time-dependent attractive forces which develop in the fluid. The longer the fluid is static, the longer the fluid is static, the stronger these forces become. So the gel structure should be easily broken. In simple terms, the gelling of the fluid, you know, like you take a jelly, or you like Swiss, right? So when the fluid is static, it should form a gel structure. And this structure should be reversible, means easily broken. The gel properties are especially important for deviated and horizontal wells, as the distance solids have to settle is very small. So the gel properties must be specific and tailored to the deviated and horizontal wells. Next, minimize formation damage. As we said before, formation damage is caused by non-soluble chemicals, maybe caused also by debris, maybe caused by clay particles or solids plugging the pores. So we avoid all this by using a non-damaging reservoir-friendly fluid. And let us go with the reasons. As we said before, formation swelling, the clay and soil formations, washouts, and this can result in difficult control and poor hole cleaning and all of this stuff. Next, the need for inhibition. As you see in front of me, this is the hole, and we are controlling the swelling of the shale by certain type of chemicals called shale inhibition chemicals. Maybe salt, maybe specialized chemicals, or any other stuff. Minimize the formation damage. Minimize the formation damage, as we said before. The solids blocking the reservoir pores, the emulsion droplets blocking the reservoir pores, anything restricting the porosity of the formation or restricting the productivity of the formation is called formation damaging subjects. Also, the swelling clays in the reservoir and ions from the formation and drilling fluid forming insoluble salts. Damage by drilling muds. Mud damage can occur by physical reduction of the pore throat size and relative permeability reduction. This is what we said before in simple terms. Next, this is so specialized formation, no need. This is interesting, guys. You can see the clay particles when they are swelling and they are surrounding the pore throat, so you can produce easily. This is called kaolinite, by the way. This clay is called kaolinite, and you can see the clay sheets in front of you. The damage due to relative permeability reduction. How the permeability can be reduced? Maybe due to wettability change. What is meant by wettability change? Every reservoir in the world, it is water wet. Means that water relatively stick to the surface of the reservoir rock, so you can suck the oil without water. If you change the wettability of the reservoir rock, the reservoir oil will be more relatively sticking to the rock, and the water is free, so you can produce more water. You know that every reservoir has a water cut. There is no just oil you see in under. You see oil and some gases, and maybe water and oil only. So if you want to maximize the production of the oil, you need to preserve the wettability of the reservoir. Depth of the invasion, it is called by the drilling fluid when you have no filtration control. So a lot of drilling fluids enter the formation, causing problems for the logging crew, for the formation evaluation, and of course damaging the reservoir. Isolating fluid from the formation. The isolating the fluid of the formation means to decrease the losses, because losses are expensive and maybe cause well controlled problems. Because if the column of the mud is decreasing in the well, then you can't preserve the pressure in the well, and that may cause a lot of problems. The filter cake reduces the flow of the fluid into the formation, and you can make a filter cake. Filter cake is something that lining the well. It is like a building material. You build a wall inside the well, homogeneous wall should be. It reduces the transmission of fluid into the formation. It should be thin with a low permeability. For cooling and lubrication, as we said before, you need to cool the drilling bit because there is too much heat downside. What is called by the borehole temperature. And that can be happen by using a huge mass system. So there is a heat exchange on the surface. So the fluid itself is carrying the heat from downside and exchanging the heat outside. For cooling and lubrication, we may use oil-based mud because oil-based mud is more lubricative than water-based mud. How to power downhole tools using the drilling fluids? By using certain GBM and certain piece of the equipment downside, mostly called motors. They convert the GBM we are using to build the inclination needed. They build the inclination needed by maneuvering the GBM up and down to a certain value. Transfer information from measured equipment to the surface. This is done by the pressure pulsing. Pressure pulsing is done through the fluid itself. The environmental impact. We should reduce the environmental impact, of course, by controlling the waste we are disposing to preserve the marine environment and the life of the living creatures around us. Also, when you are walking on shore, you should dispose the waste materials in an appropriate way to preserve the aquifers, the water wells, and the life of every living human and animal. How to maximize the whole information? This is drill cuttings as we have talked about. Maximize the whole information by maximize the whole information by the cleaning the cuttings and preparing the cuttings in the appropriate way. You know that there is a type of work called mud logging. They took the samples into dry samples and wet samples, and they can use it for their benefit. They can analyze the samples, analyze the cuttings, you know the formation you're drilling, you know the type of the grains you are drilling, and you know the type of rock you are drilling, and so you know which particular and specific type of mud you need to use, and which particular and specific type of drilling parameters you can use. So you can drill efficiently, you can drill safely, and you have a good well and good income of money. How we can treat the corrosion? As we said before, that muds, most of muds are alkaline. So alkalinity and high pH preserve the pH. Sorry for that. Corrosion can lead to washouts, twist-offs, pump failure, surface leaks. You know, all of the drilling equipment, are metal, so they are exposed to corrosion in any way or in any piece of the equipment, which may cause washouts. Washouts means some like pitting, and when pitting increase, it causes holes in the metal. Maybe cause loss in the drilling flows, loss in pressure, and too much problems in the well. Support is a part of the drill string, of course. How we can support part of the drill string? You know that when we are in fluid, the fluid carry part of the weight. So the fluid is carrying part of the weight of the drill string, which maybe facilitate the drilling process. The cost and the penetration rates. When you maximize the penetration rates, means that you drill the well in a faster time, and in a shorter time means less money to spend to have. So of course, maximizing penetration rates is one of the most interesting subjects nowadays we are talking about. And it can be enhanced by removing cuttings, maximizing the removing the cuttings from the well, and reducing the cushioning effect of solids, which is something caused by bad hole cleaning. So if you have a good hole cleaning, then you have a good penetration rates. Also reducing the hydrostatic differential. The hydrostatic differential means the difference between the bore pressure and the pressure exerted by the drilling fluid, also increasing the jet velocity. As we talked before about the hydraulic horsepower and the impact force acting on the formation to maximize the drilling process. This is the well coast, and this is the key drilling issues we are talking about before. To maintain the borehole stability, suspend bright and solids under static and dynamic conditions, remove drilling cuttings from the hole, of course, provide hydraulic horsepower to the pit, minimize loss of flow to the formation, control formation pressure, and to lubricate the drill string. That's it from my side, guys, and our session is finished today. Kindly, if you have any questions,